Now case 3 is if f of x is equal to sine hyperbolic or cos hyperbolic, yp is equal to 1 upon phi of d square sine hyperbolic ax plus b. For a while consider you have only sine hyperbolic ax plus b, then in that case you have to replace d square by a square only. Okay, in case of trigonometric functions sine and cos, we were replacing d square by minus a square. In case of hyperbolic functions you have to, यहाँ पे h दिखा कि आपको क्या करना है, d स्क्वायर को a स्क्वायर से रिप्लेस करना है. ठीक है, और अगर फाई ऑफ ए स्क्वायर ज़ीरो आता है तो आपको सेम करना है जो हम केस 2 में करते थे. न्यूमरेटर में x लेना है और डिनोमिनेटर में फाई डैश डी स्क्वायर फाइंड आउट करना है और उसमें डी स्क्वायर को ए स्क्वायर से रिप्लेस करना है. अगेन इफ फाई डैश ए स्क्वायर इज ज़ीरो देन यू हैव टू डू द सेम थिंग, इंक्रीज पावर ऑफ x in the numerator and in the denominator you will have phi double dash at a square. Okay, do the same thing up to the term where you get denominator as non-zero derivative. Okay, non-zero derivative at a square. Now case 4, so if f of x is equal to x raised to m, where m is any positive integer, then in this case we have to use three formulae. 1 by 1 minus x is equal to 1 plus x square plus dot dot dot. Second binomial theorem is 1 by 1 plus x is equal to 1 minus x plus x square minus x cube plus dot dot dot. And the last one is 1 plus x raised to n is equal to 1 plus nx plus n into n minus 1 divided by 2 factorial x raised to 2 plus dot dot dot. Okay, so we have to use any of this formula to find out yp. In this case just you have to convert yp is equal to 1 upon phi of d operating on x raised to m. So you have to convert this 1 upon phi of d as phi of d raised to minus 1 x raised to m. Okay, so depending upon the problem you will have expansion for this phi of d raised to minus 1. It depends on phi of d, what phi of d, which phi of d you have. Okay, so we will consider one example. Consider this example. So d square plus 5d plus 4 times y is equal to x square plus 7x plus 9. Now all of you can find CF. Okay, if you don't know how to find CF, then go to our channel and see the video of complementary function. Okay, first video of LDE. So CF, you will get CF there. Now to find PI, yp is equal to 1 upon phi of d. In this case phi of d is d square plus 5d plus 4. Operating on right hand side function is polynomial, quadratic polynomial you have. Okay, now you have to rewrite this denominator phi of d as 1 plus some function of d, constant free function of d, or 1 minus some constant free function of d. Now you don't have minus anywhere here in this phi of d, so you will get 1 plus some function of d. So to obtain 1 you can take 4 in common, or you can write 4 as 1 plus 3. But why we don't write 4 as 1 plus 3? Because if you write it as d square plus 5d plus 3 plus 1, then you will have d square plus 5d plus 3 as your x in this case, and after taking power series expansion for this 1 plus x, you will get this constant term everywhere in that expansion. Okay, and this constant term multiplied to this will be an infinite sum. Okay, you will have. So we reject to do this. What we do, we take this 4 in common. Okay, take this 4 in common, so you will have 1 inside the bracket. So after taking 4 in common, you will have 1 plus, write this 1 at first place and then write d square plus 5d divided by 4, because you don't have 4 as multiple in this case, so we have to divide. We are taking 4 in common, so we'll divide d square by 5 plus 5d by 4. Okay, operating on x square plus 7x plus 9. Now yp is equal to, take this 1 by 4 outside. Okay, 1 by 1 plus d square plus 5d by 4. Okay, operating on x square plus 7x plus 9. Now you can observe this is 1 upon 1 plus x. This is of the form 1 upon 1 plus x. Okay, so what is your x in this case? It is d square plus 5d divided by 4. So use formula for 1 by 1 plus x. What is the formula? 1 minus x plus x square minus x cube plus x raised to 4 dash dash dash. Okay, use it. So yp is equal to 1 upon 4. Use the formula. Okay, so 1 minus x in this case is, x is d square plus 5d divided by 4. Okay, plus d square plus 5d divided by 4 bracket square minus dot dot dot. Why we are not taking further terms? Because you have d as differential operator. Okay, you have quadratic polynomial on right hand side. That means first derivative of quadratic polynomial, what is the first derivative? First derivative is 2x plus 7. Second derivative 2, and third derivative 0. So in general, for any nth degree polynomial, you will have n plus 1th derivative 0. Okay, so we have to take the terms. These are all differential operators. So if d raised to 3 is 0, d raised to 3 of this polynomial is 0, then why we have to write d raised to 3 here? Okay, we will not write d raised to 3. So we have to collect all the differentials that are non-zero of this polynomial. Okay, so yp is equal to 1 by 4, 1 into x square plus 7x plus 9, so x square plus 7x plus 9, minus into bracket d square is what? D square is second order derivative. You have already found out what is the second order derivative. It is 2 simply. Okay, so 2 plus 5 times first order derivative. D is what? First order derivative. So 5 times first order derivative of this, it is 2x plus 7, that is 10x plus 4 plus 5 sevens are 35. Okay, divided by 4, plus what about this? What about this? This is d square plus 5d bracket square. So that means this is d raised to 4 actually. Okay, so fourth derivative is obvious 0 because this is quadratic polynomial, and third is 0. So fourth is 0. Fourth is 0, third derivative is 0. So this expansion will have d square, d raised to 4, d cube and d square. So only second order derivative is possible. So 5d square will be 25. 5d by 4, square of 5d by 4 will be 25d square by 16. Only this term will be non-zero for this bracket. Okay, so 25d square, that is 25 second order derivative, it is 2. So 50 by 16. This is the last term you have. Minus all further derivatives are higher order derivatives, and this has only second order derivative non-zero. All further derivatives are 0. So we are not collecting further derivatives. Okay, so yp is equal to 1 by 4 x square plus 7x plus 9 minus 1 by 2. Okay, separate this, so you will get minus 1 by 2 minus 5 by 2x minus 35 by 4 plus 50 by 16. This is your required yp. Now you have to collect all like terms together. Okay, so 1 by 4 into bracket x square is the one and only. Okay, plus 7 minus 5 by 2. 7 minus 5 by 2 will be 7 2s are 14. 14 minus 5 will be 9. So plus 9 by 2 x. Constants 9 minus 1 by 2, 17 by 2 plus 17 by 2. Here it is, you have 16, so 35 fours are, do this on calci, okay. 35 fours are, I think 35 fours are, 4 5s are 20, okay. 4 3s are 12 plus 2, 140. So 140, 50 minus 140 divided by 16. These are two fractions with denominator 4 and 16. So we are going to take denominator 16. So multiply this ratio numerator and denominator by 4. So in the numerator you will have minus 140, and in the denominator it is 16. Okay. Now the denominators are same. So I have written down denominator collectively 16. Okay. And in this way it is equal to 1 by 4 x square plus 9 by 2x (50 minus 140 minus 90). Okay, so minus 90 by 16. Again you can divide by common factors. Okay, so yp is equal to 1 by 4 x square plus 9 by 2x minus common factor is, you can divide by 2 only. Okay, so 45 divided by 16 by 2 is 8. This is your final answer. This is 5 yp. So the key step is, you have to take the constant term in common. Okay, and all further steps are easy to understand. Okay, you have to take this 4 in common and then do the usuals. Use 1 upon 1 plus x. Okay, study derivatives of polynomials and you will understood. Okay, thank you.